Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. Our topic today is the mind-brain relationship, and my guest is Dr. Karl Pribram, a professor of neuropsychology at Stanford University in the Department of Psychology and in the medical school. Dr. Pribram is the author of Languages of the Brain and hundreds of articles about the mind-brain relationship. In fact, I would say fairly that Dr. Pribram is probably one of the most influential scholars alive today in probing the mysteries of the mind-brain relationship. Karl, welcome to the Mind's Eye.
Thank you.
It's a pleasure to have you here. You know, many academic psychologists, and perhaps you have some sympathy for this point of view, over the years have taken a perspective which laymen tend to laugh at times, and they claim that the mind doesn't exist. I wonder if you can explain that perspective and talk about what we mean, or what you mean by the mind.
Well, I don't like the term the mind because it reifies. That means it makes a thing of something that's a process. We pay attention, we see, we hear. Those are all mental processes and mental activities. But there isn't a thing called the mind. There might be something you might want to call yourself, but the mind sort of make something concrete out of something that's very multifaceted.
And yet somehow when I'm aware of myself being aware, I think that, well, that's my mind that does that.
That does that? But your mind doesn't. I'd have to think about that. Yeah.
You're very well known in psychology and neuropsychology as the developer of the holographic or holonomic model of the brain. Can you talk about that a little bit and how it relates to the mind, or to the mind-body process?
Okay.
I have to be on my toes with you today.
Yes. The holonomic brain theory is based on some insights that Dennis Gabor had. He's the inventor of the hologram, and he obtained a Nobel Prize for his many contributions. He was a mathematician. And what he was trying to do is develop a better way of making electron micrographs, improve the resolution of electron micrographs. And so for electron microscopy, he suggested that instead of making a photograph, essentially, not with electron microscopes, we make photographs but using electrons instead of photons. Right. And he thought maybe instead of making ordinary photographs, what he would do is get the interference patterns. Now, what is an interference pattern? When light strikes or when electrons strike any object, they scatter. But the scatter is a funny kind of scatter. It's a very well-regulated scatter. For instance, if you defocus a lens on a camera so that you don't get the image falling on the image plane, and you have a blur, that blur essentially is a hologram. Because all you have to do is refocus it.
So contained in the blur is the actual image.
That's right. But you don't see it as such. And so one of the main principles of holonomic brain theory, which gets us into quantum mechanics also, is that there is a relationship here between what we ordinarily experience and some other process or some other order, which David Bohm calls the implicate or enfolded order, in which things are all distributed or spread. And in fact, the mathematical formulations are often called spread functions that spread this out.
Now, what you're talking about here is the deep structure of the universe, in a way, under beneath the subatomic level, virtually.
That's right.
Of matter itself are these quantum wave functions, so to speak, and they form interference patterns, would I be wrong in saying it would be like dropping two stones in a pond, the way the ripples overlap? And is that like
Certainly
an interference?
That's certainly the way interference patterns are made.
And you're
yes.
suggesting that at that very deep level of reality, something is operating in the brain itself.
Well, no.
Okay.
In a way, that's possible, but that's not where the situation is at the moment.
Okay.
All we know is that the mathematical descriptions that we make of, let's say, single cell processes and the branches from the single cells and how they interact with each other, not only anatomically but actually functional interactions, that when we map those, we get a description that is very similar to the description of quantum events.
When you take into account that there are billions of these single cells
That's right.
operating in the brain.
And the connections between them. So there are even more, there are trillions of connections between them, and they operate on the basic principles that have been found to also operate at the quantum level. Actually, it was the other way around. That the mathematics that Gabor used, he borrowed from Heisenberg and Hilbert, who developed them first in mathematics for Hilbert, and then Heisenberg used it in quantum mechanics, and then Gabor used it in psychophysics, and we've used it in modeling how brain networks work.
So, in other words, in the brain, when we look at the electrical impulses traveling through the neurons and the patterns as these billions of neurons interact, you would say that that is analogous, I suppose, or isomorphic to the processes that are going on at the deeper quantum level.
Yes, but we don't know that it's a deeper quantum level. I mean, in the brain, it's just it's analogous.
That may or may not be the case.
Yeah, analogous isn't quite the right word. They obey the same rules. They obey the same rules. It's not just an analogy, because the work that described these came independently of. See, an analogy would be that you take the quantum ideas and see how they fit to the brain, the data we have on the brain. And that's not the way it happened. We got the brain data first, and then we see, look, it fits the same mathematics. So the people who are gathering these data, including myself, weren't out to look for an analogous process. And I think it's a very important point, because otherwise you could be biased, and there are lots of different models that fit how the brain works. But this is more based on how the brain was found to work independent of these conceptions.
Independent of any model.
Yeah, essentially independent of any model.
So you've got a mathematical structure that that is parallels the mathematical structures of quantum physics. Now, what does that tell us about the mind, the brind?
The brind?
The brind.
That might be a good Australian way to say it, the brind. Anyway, what it tells me is that the problems that have been faced in quantum mechanics for the whole essentially the century, well, since the 20s, late 20s.
Many paradoxes in quantum
and very
mechanics.
many paradoxes, that those paradoxes also apply at the psychophysical level and at the neuronal level. And therefore, we have to face the same sets of problems. At the same time, I think what David Bohm is doing is showing that some of the classical conceptions, which were thought not to apply at the quantum level, really do apply at the quantum level. Now, I'm interpreting Bohm. I mean, I'm not sure he would want to agree to my interpretation of what he's doing, but to me, that seems to be what is going on. So that the schism between levels, between the quantum level, you know, the sub-microscopic almost, you know, the subatomic level, and what goes on there, and the so-called and the classical, the so-called uncertainty principles, and all of that, that all applies all the way along. But you've got to be very careful in how you know, and what, how should I put it? You've got to apply to the actual data and not just sort of run it over.
And to the average layman, why would they be interested in this? Is there some significance, say, to people in their everyday lives or in their workaday world, in the business of life?
Sure, and that is this is the critical thing, that if indeed we're right, that these quantum-like phenomena or the rules of quantum mechanics apply all the way through to our psychological processes, what's going on in the nervous system, then we have an explanation, perhaps. Certainly we have a parallel to the kind of experiences that people have called spiritual experiences, because the description you get with spiritual experiences seem to parallel the descriptions that quantum physicists. That's why Friedrich Kepler wrote Tao physics, why we have the woolly masters, and all of this sort of thing that's come along. And in fact, Bohr and Heisenberg already knew, and Schrödinger talked about the Upanishads, and Bohr used the yin and yang as his symbol.
Yes.
Because the conceptions that grew out of watching the quantum level, and therefore now at the neurological and psychophysical level, in other words, the psychological level as well, seem to have a great deal in common with our spiritual experience. Now, what I mean by spiritual experience, you talked about mental activity, calling it the mind. That aspect of mental activity, which is very human, may be true of other species as well, but we don't know. But in human endeavor, we are always somehow, many of us at least, seem to need to get in contact with larger issues, whether they're cosmology or some kind of biological larger issue, or a social one, or it's formalized in some kind of religious activity. But we want to belong. And that is what I define as the spiritual aspects of man's nature.
Some sense of relationship to the larger cosmos, to the world about us.
And that part has this implicate order. It has the explicate order too, the ordinary space-time order. I mean,
I want to stop for a second, because you're using Bohm's terms of the implicate order, and we haven't really quite defined that.
It's the holographic. You described it very well with the pebbles and all that.
Okay.
It's a set of relationships.
It's the fuzzy picture.
Well, yes, and you can talk about it in terms of waves, or you can talk about it in terms of mathematical matrices, which have vectors in them and so on. You can have them continuous vectors, or you can have continuous matrices. You can have all kinds of relationships between. When you look at a photographic plate that has a hologram on it, you can either look at some of the swirls in there, or you can look at the individual grains of silver. So there are all kinds of mathematics, but they all fit together, whether it be Schrödinger's equation, which is a wave equation, or Heisenberg's more matrix. These are not relevant to the ordinary person, but I just want to say it here, because otherwise we get stuck in the wave as if it were all waves, and that's too simple.
But what you're saying, if I can try and simplify it, is that there's a level of reality at which things are what they appear to be. I look at you and I see a body and a face, and then there's another level, let's call it, that would be the explicate level, where things are what they appear to be. Then there's an implicate level, which is just as real, but if you were to look at it, it doesn't look at all as the
We experience it entirely differently
Yes.
as a spiritual aspect of our being, or this implicate order is also a potential order. We're not in it most of the time, but we had for years this whole idea of the human potential.
Yes.
And I think that's what we're talking about.
Human potential may be embodied somehow in the implicate structure.
That's very nice, yeah. Good way to say it.
And prior to the development of quantum physics and the holonomic model of the brain, people based their notion of who they were and how their minds worked on more of the Newtonian classical models of physics, and perhaps in some sense, if they bought into those models, would tend to deny their spiritual experiences or not really feel connected with that part of themselves. Would you say so?
Very definitely, and just to recall something that de Tocqueville said after writing his histories, he said, maybe I've been interpreting it the wrong way, He said, because I've been doing it in terms of classical mechanics with cause and effect relationships, but when a human being acts, this is not a cause, this is a challenge.
Who wrote the books on
De Tocqueville in America.
Capitalism and a Democracy
in America.
Oh, yes.
See, it's when we act, it's a challenge, and that's very much a quantum type holographic implicate order idea. Rather than having causality.
It's moving towards a goal.
No, it isn't.
Oh, all right.
It's a challenge. It's different. Moving toward a goal would still be causal. See, we don't even have a good language to talk about all this. It's a challenge. The whole system can reorganize on the basis of this challenge, and you never find out where the cause is. We were talking earlier, you know, you said, where does a will start?
Yes.
Well, it's a challenge. The whole system does it. There isn't a start and a next and so on, because time and space are enfolded.
Yeah.
And therefore there's no causality.
It's all just emerging.
It's emerging, and you can challenge the system and it will respond in an unpredictable way.
You know, I must say I'm a little bit surprised, because you described yourself earlier to me as a positivist of
Right.
sorts and a behaviorist, and in a way the language that you're using seems very much like the language of the Buddhists, who talk
Sure.
about no self and just process.
No thing.
No thing,
One of the chapters I wrote once was the nonsense of no thing. In other words, the nonsense of nothing, but it's it's non-sensory, because senses are lenses, and as David Bohm has said so well, if you take the lenses away, you've got a hologram. Lenses tend to reify, to objectify, and make particles. Take the lenses away, and you've got this distributed.
So part of our mind-brain process functions as a lens, then.
Well, certainly the senses do.
Yeah.
Right.
What about the other functions of the mind? Memory, learning.
Of what?
Caught me again. It's such a habit.
What other mental functions? It's easy to say it without reifying it, especially if you want to be holistic about this. One of the things, in answer to your previous question, just a second, if I may interrupt,
take your time,
is that you said I'm a positivist, and you know, the hard-nosed kind of scientist, in my experience, when we were stimulus response scientists, that became very soft after a while, and the cognitive, which was the hard-nosed kind of science, which was soft, became the hard-nosed one. And I'm quite sure that the kind of definitions I'm giving are just as hard as anything that ever was in stimulus response psychology.
In other words, at some point it will become to be seen that if you talk about spiritual experiences, if you refer to Buddhists and mystical concepts, that can be
just
taken in terms of very hardcore.
Well, it's up to scientists to do this. It doesn't come automatically.
Very rigorous.
Yeah, well, you don't want to get into rigor mortis in this, but yes, I mean, you want to be able to see, science, the beauty of science is that it's basically based on sharing. Now, the more carefully and clearly I can define something, and the reason we want to quantify is not because we're interested in quantities, but because then you can communicate and share much more clearly than if you can't have quantities. So all of science is based on the notion of sharing. And if we can define things, if some Buddhist tells me, you know, I've just had an aha experience, or I've just seen the light, and I don't know what the hell he's talking about, then I can't share that. But if he gets me to have the same experience, that begins to be science. And if I can make definitions so I can describe to you what is going on, let's say that the pineal is secreting some substance that makes you suddenly flash, or something of that kind.
Bufotenine.
Yeah, you know, then we have some way of sharing this experience, which goes deeper than when we're sort of just stunned by somebody saying, yes, I've seen the light. I mean, that may be just metaphorical, whereas it may actually be that it did produce a reaction akin to stimulation of the visual system, so on and so forth.
Well, you're raising many issues here.
Yeah.
I don't want to get
Okay.
too off
No, my
track,
point is
though.
simply
Yeah.
that this business of what's soft and what's hard keeps changing.
Yeah. Well, that's a very important
Right,
point.
and my prediction is that the kind of thing we're dealing with here will be seen as solid and as scientific in the 21st century. They'll look back at some of the fuzzy stuff that was going on in the name of behaviorism.
Many scientists, neuroscientists today, it's almost axiomatic when they talk about the mind, which they sometimes do. They say the mind is sort of located in the brain. I gather that way of putting it is totally discordant with your own view of things.
Yes, I think, I mean, there are lots of different ways of phrasing this. One is that mental phenomena are emergent properties of how the brain works, and so they, you know, it's almost like the brain is secreting vision and mind and all that. But maybe a better way of talking about it would be to say that mental phenomena arise through the interaction between brain and body and the environment. And that whole interactive, this is sort of what Karl Popper says, that whole interactive thing produces an emergent, which we call mind and spirit and so on. And I think that's a better way than just thinking of the brain secreting it.
Now, how does this model relate to human potential? If I want to cultivate my various potentialities, my skills, reach into the implicate order and make some of it more explicate, do you have notions about that for learning, for human development?
Well, you said it yourself just now. You reach into the implicate order. You allow yourself. Freud called it regression in the service of the ego to primary process kinds of things, which are more holonomic, more holographic-like. Yeah, I think that's the general way that I would say that this is different. The other is imitation, and the kind of thing that we have role models and we take care of ourselves in terms of model ourselves on someone, and kind of thing you do in sports when you watch a videotape or something.
And would you say creativity works the same way?
Well, creativity works the same way in the following sense, that we allow ourselves to get, let's just be very crude here, into this wave form where, you know, we're a distributed system. And this then allows the fluctuations that take place there to create new forms, which in space-time we can't really do too well. I mean, things are already formed. But if we get back into this potential of distributed implicate type of order, then these fluctuations have a chance to reorganize as well, or to organize new foci of activity.
And these would take the shape of mental images in our mind?
By the time they get to be mental images, it's already pretty well set into space-time form.
What is a mental image in space-time? How would you describe that as a neuroscientist?
Well, I've got my image of your face right now, and I also have an image of Brooke sitting in a chair over there, and a big eye looking at me in front, a television eye, with my eyes closed. I mean, that's mental imagery.
You wouldn't try and tie that to resonant neural patterns? Or,
oh, sure.
Yeah.
I'll be happy to do that. There are two kinds of mechanism. I mean, you can sort of divide things up into 2s and 3s and so on. But if you divide neural activity, you can divide it into propagated nerve impulses on the one hand, and then these slow potentials, hyperpolarizations, depolarizations that don't go anywhere. And they form this sort of holographic-like pattern. And it's those that I feel, and you know, have some evidence to support this, are what we experience as
would
imaging.
these sort of be like standing waves in the mind?
Well,
Am I reaching too far here?
you said it in the mind again.
Oh,
The waves aren't in the mind.
standing waves in the brain.
In the brain,
Yeah.
they could be thought of that way, or as, again, I use the matrix analogy as well, just so we don't get too far into the waves. But sure, some kind of standing waveforms that are there temporarily. Sometimes they last longer, and sometimes they're very brief, and we are not even aware of them. But the longer they last, or Sherrington had this idea, and he said there seems to be a reciprocal relationship between reflex and mind. The more reflex, the less mental, and vice versa.
Oh, okay. That relates somehow to free will also, I gather.
Well, there we get into the whole a different set of problems now. Sure, to some extent, if you get into your potential mode, then new fluctuation, new things can happen. But usually free will is conceived of in terms of how many constraints are operating. And we have in statistics a notion of degrees of freedom.
Yes.
And I think our will essentially, is constrained, more or less. We have so many degrees of freedom, and the more degrees of freedom we have, the more we feel free, and we have freedom of choice.
Well, what can we say in wrapping the program up, given all of these aspects of the mind-brain system that you've described, how does that relate to, say, the ultimate or the farther reaches of human potential?
Well, I think in the 21st century we're going to be able to do an awful lot that we weren't able to do up to now, simply because science will be admitted to the spiritual aspects of mankind, and vice versa, that what has been segregated for at least 300 years since Galileo, where the spiritual aspects of, in Western culture at least, have been sort of relegated over here, and people have split this, We build buildings and we do surgery and do all of these things, and then if we have a spiritual aspect to ourselves, we go do that somewhere else.
Separate.
Whereas now, I think these things will come together, and it'll be perfectly all right for what we today call, in quotes, faith healers to come and help with reduction of pain and to ease all kinds of things. So, it'll be a different world. I wouldn't even be surprised if preventative therapies could be instituted, so we don't have to, because they deal with controls of ourselves, so we don't aren't as prone to get cancers.
That's very optimistic. Well, Karl Pribram, it's been a pleasure having you with me. Thank you very much.
Well, you're welcome. It's been a pleasure being with you, too.
And thank you very much for being with us.